All right, so this question is a little more, it's a little different than the previous ones because the object is not resting horizontally. It's not moving horizontally. In fact, it's not moving. The question says that the physics textbook is, Maya leaves a physics textbook on top of a ramp that's inclined at a 35-degree angle. So the free body diagram is here, and we want to find the net force acting on the book. So we're going to do this by adding up the forces, but what makes this question a little different is that the book is not horizontal, it's on this slope. So the easiest way to approach this question is to do what the hint tells you to do and rotate the axes so that they're perpendicular and parallel instead of horizontal and vertical. So normally if you had a book resting on a surface, let's say your book was here, you would make your X and Y like this, right? The normal up and down. But what I want you to do is just imagine rotating these axes so that they align with the potential movement of the book. I'm going to erase this so we're not confused. But you can see from this diagram that the y-axis is up here and the x-axis is down here. So what that does is it makes the normal force, which is this, let me redraw these forces in red. So the normal force, which is up here, this is the normal force. They're calling it the table on the book. It's the support force. It's now directed entirely in the y direction. And the frictional force, which is this way, is directed entirely in the x direction. The one that we have to look at now with a little more detail is gravity, which Fg is sort of in between the two, Fg. It's not x, it's not y, so we're going to have to look at that. I want to also investigate what this says here. The ramp is angled at 35 degrees. So what that means, just sort of zooming in on this picture, it's not great resolution, but if you were to draw the horizontal like this, what they're saying is this angle is 35 degrees. Okay, so now we have to do some figuring out. I'm gonna move this vector, this force vector over here. So imagine this is my force vector, and this is my slope, and this is the horizontal. This is the horizontal. So you see, and let me see. So we can get rid of this a bit. So that's what we have. And what we've said is this angle is 35 degrees. What I'm going to do is draw my axes, and my axes are parallel and perpendicular. So my y-axis is going to be right here, and my x-axis is going to be exactly along the slope. So now that I have that, I can put in my x and y coordinates of the force of gravity. This is the force of gravity acting straight down, and what I can do is make my y component parallel to the y-axis. So this becomes FGY, and then my x component is this, and it's parallel to the x-axis, and this is FGX. So I've created components, and sometimes it's a little tricky, but what I want you to notice here is I've made a right angled triangle with one component parallel to the y-axis and one component parallel to the x-axis. Okay, so FGY is along the y and FGX is along the x. The question then becomes, what is this angle? And we can solve it by solving these right angled triangles. So we've got 35 degrees over here. That makes this angle 90 minus 35, which is, what's 90 minus 35? 90 minus 35 is 55 degrees. So if this angle in here is 55, that leaves us with another 35 degree angle here. This is something I want you to slow down and take a look at. Ask me questions if you have it. Hopefully we did it in class and you're seeing it a second time now. It takes practice to get better at this. So when I put my 35-degree angle there, what I'm going to do is solve this triangle. Ultimately, what we want to solve for is what is FGX and what is FGY. And we're going to solve the triangle. Well, FGX, if you look at this triangle, you can see that FGX is, let me do this. FGX is the opposite. This is, so if 35 degrees is my angle, this is the opposite. This is the hypotenuse, and this is the adjacent, okay? And so, using that, I know that I want to find FGX. So I've got opposite, it's opposite the 35. So what I'm going to say is sine 35 equals opposite over hypotenuse, which is FGX over FG. So if I want to solve for FGX, it's equal to FG sine of 35. I want you to remember what FG equals. FG, the formula we have, remember this is F sub G equals mass times acceleration due to gravity. Actually, we don't need this. Sorry, let me back up for a second, because they tell us FG. They tell us the force of gravity on the book is 22 newtons. Oops. Didn't want to do that. I wanted to do this, 22 newtons. So we can then put in 22 sine 35. So this is what FG is going to be, FGX is going to be equal to. And doing that math, we can get, let's see, I think I have it here somewhere. I think it's 12.6. You can do it at home. 12.6 newtons. So that's what FGX equals. Now let's look at, so zooming back out for a second, now let's look at FGY. Well, FGY is, as you can see, the adjacent, right? So if that's the adjacent, then we can say cosine of 35 equals FGY over FG. And then we can say FGY equals FG cosine 35, 22 sine 35, and putting that into your calculator and figuring out that number, FGY works out to 18 newtons. So now we have these two things. We have FGY and FGX and FGY. Now going back to the big picture, we're trying to find the total force or the net force. All right, so what we're going to do is pick a dimension, just like we did before. Let's start parallel to slope. And remember, this is the x direction when I'm parallel to the slope. So same as before, F net equals, and F net in the x direction equals sum of the x forces. So this becomes, now what's acting in the x direction? We should probably pick a sign convention. So I'm going to make this direction of x positive and this direction of x negative. So positive, I've got, you see how this green vector here is pointing in the positive x direction. So I'm going to say it's it's FGX minus FF. Hopefully that makes sense to you. So then plugging this in, I get 12.6 newtons minus 11 newtons, which equals 1.6 newtons. So my F net in the x direction is 1.6 newtons. So that's one part. Now let's go perpendicular to the slope. Or in the y direction. So now same idea, F net in the y is equal to the sum of the forces in the y direction. Now what's acting in the y direction? Well, there's, again, we can choose our sign convention. We pick up to be positive and down to be negative. So the up force is the normal force, and it is So Fn minus, because it's down, and we've got the y component. Again, if you look at this force here, that's the force acting down perpendicular. So then we can say this is equal to minus Fgy. Then plugging in the numbers, I get Fn is 18 according to the diagram, minus, and then what we calculated was 18 newtons. So, oops, go with it. So what that means is 0. So this equals 0. So F net in the y is equal to 0. And that's fortunate because otherwise it would be a little more complicated. So because if I was to do the components of these two things, there's no y component. So therefore I can just make the statement that F net equals 1.6 newtons, and I'm going to put a direction. It's angled in the direction down the slope, because that's the positive. My vector was positive, so this is down the slope. And that's your final answer.